And on this specific project, we are dealing with revenue management in airplane ticketing. Revenue and yield management basically deal with determining the correct prices and the correct amount of tickets to sell at a specific time in order to optimize your revenues. And for this specific example, we are dealing with a strategic alliance between operating carriers and ticketing carriers. Operating carriers are the actual airlines, and ticketing carriers are all those search engines for traveling, such as Expedia, Kayak, and many others. The mathematical model basically deals with maximizing the ticket carrier profit contribution, which is done by the ticket price, the summation of the ticket price minus the option price and the strike price, and subject to some important constraints, such as that the limits must be less than the summation of the expected demand, and that the summation of the limits must be less than or equal to the contribution. And for the literature review, I selected a specific article called An Option-Based Revenue Management Procedure for Strategic Airline Alliances from the European Journal of Operational Research. And it starts describing how we want to select how many seats we want for each customer, and we want it at the higher price. So this is a revenue management is an instrument which gives you a solution to a decision problem. So there's a explanation on how the operating carriers and the ticketing carriers work together as a strategic alliance, and there's a picture of the aircraft operating carrier and how many seats are available only for the operating carrier to sold, and how many seats are available for the ticketing carrier to sold. And as we can see, it gives us our mathematical model, which is the ticket price minus X and K, which are our option price and spot price. And it also describes that the model's objective is the maximization of the ticketing carrier's profit contribution. It includes some constraints as well. And now it's time to take a look at our SAS OR model. So first we input our data, we write how much we want of each class. First class, business class, and economy class. Next we write the price for each of these. We state our demands, how much we want of each, what's the limit. And then these are some SAS macro variables, which we call later on in our optimization model. And we start our optimization model. And some of the important constraints we define here is that we want to enforce one price level per class, as we can see here. We also don't want our sales to exceed our demand, and this is clearly stated in our article that the limits must be less than or equal to the demand. And after all this, we state our objective function, and in this specific example we divide it by periods, which are the same seasons, and we use if statements to divide these. And after all this is done, we print and solve our model, and in this specific case we have an unknown objective function when we run it, and this is because the SAS macro variables are not read properly in the enterprise guide. Therefore, this is an area that needs improvement. So I decided to implement an Excel model as well in order so that you guys can clearly understand the problem. So I'm going to briefly go over it. First of all, we have our seasonal factors, which means that how much of the actual price are you going to pay, and this depends. If you buy an early booking, you're going to pay just 90% of the actual price. If you have a regular booking, which is when most people buy their tickets, which is 2 to 3 months earlier, you're going to have the actual price. But if you buy it last minute, you're actually paying 110% of it, so you're paying extra. And after we have this, we subtract it from our option price and our strike price, and our objective function does that. And now we solve our model, and as you guys can see, it gives us our variables, and these cannot, there's a constraint that it cannot exceed the expected demand for season 1, option 1, and we have our classes and our options. And I have added some bounds so that you have to set at least 5% first class and at least 75% economy class, and the maximum is at most 12% of first class. So this helps so that you stay within the bounds. And comparing our model to our actual article, we did incorporate the option price and the strike price, and we considered all the constraints that were implemented here. And some of the differences that we can see, for example, in our SAS OR model, we used if statements to separate each season, because here some scenarios are added besides the seasons. So that's what makes it a little bit more complex. And we can see that there actually is major significance with our article, as we can see that it does determine that the ticketing for an optimal ticket carrier profit contribution, we want to sell more economy class in early season, and the ticketing carrier wants to get more of the business and first class in the last minute. And this makes a lot of sense, because usually economy class people plan ahead to get cheaper tickets, so the ticketing carrier considers this. And the last minute, you want to business class and first class, because that time is usually not an issue for this, as many times the company pays for it. And to summarize the presentation, the model implementation can be implemented both on Excel Solver and on SAS OR. It needs some minor improvements on SAS OR, but it still successfully was implemented, and the model can be applicable to determine many things, such as strategic alliances between carriers, when some carriers need to buy tickets and when they don't, and at what point in time they need to do it. It also is helpful to determine limits on how many seats should be sold at the time, and it does define restrictions on the pricing. And I could improve this model by resolving the macro variables in the SAS OR, expanding some of the options, adding seasonal variations, and including the overbooking option, such as many airline companies overbook their flights to optimize their revenue. And after understanding revenue management, you can just go and buy your ticket. Thank you guys for watching.